Hello everyone, welcome to today's presentation. I'm excited to share with you a fascinating topic, the summary by Class Cloud on the structure of the atom, specifically for Class 9 CBSE. In this session, we'll explore the basic structure of atoms, understand their components, and get a clear overview of how atoms are organized. So let's get started and dive into the world of atoms. Let's talk about the discovery of subatomic particles, which are the building blocks of atoms. First, we have the electron, which was discovered by J.J. Thomson. Electrons are negatively charged and very light compared to other particles. Then, there's the proton, discovered by Ernest Rutherford. Protons carry a positive charge and are much heavier, approximately 2,000 times the mass of an electron. Finally, we have the neutron, discovered by J. Chadwick. Neutrons are neutral, meaning they have no charge, and their mass is roughly the same as that of protons. All these particles, electrons, protons, and neutrons, together make up atoms. Understanding their roles helps us grasp the structure of atoms, which is fundamental to our overall understanding of matter. So, in summary, atoms are composed of these tiny particles, each with unique properties, and their discovery was crucial to advancing atomic science. Now, let's look at the different atomic models that have helped us understand the structure of the atom. Starting with Thomson's model, often called the plum pudding or watermelon model. In this model, the atom is thought of as a positively charged sphere with electrons embedded within it, kind of like raisins in a pudding. This model could explain why atoms are neutral overall, since the positive and negative charges balance each other out. However, it couldn't account for some experiments, particularly scattering experiments, where particles were deflected unexpectedly, indicating that there was more to the atom than just a uniform positive charge. Next, we have Rutherford's model, which came from his famous gold foil experiment. Most alpha particles passed straight through the foil, but a few were deflected at sharp angles. From this, Rutherford concluded that the atom has a dense, positively charged nucleus at its center. Electrons orbit around this nucleus, and most of the atom is actually empty space. However, there's a problem here. Classical physics suggests that electrons revolving around the nucleus should lose energy and eventually spiral inwards, making the atom unstable. So, while Rutherford's model was a huge leap forward, it still had some limitations. That brings us to Bohr's model. Bohr proposed that electrons revolve around the nucleus in specific, fixed orbits or energy levels, which he labeled as K, L, M, and N in these orbits. Electrons do not lose energy, which explains why atoms are stable. This model was crucial because it helped us understand how atoms emit or absorb specific amounts of energy, corresponding to transitions between these levels. So, in summary, each of these models contributed to our evolving understanding of atomic structure, moving from the idea of a uniform positive sphere to a more complex picture with a nucleus and fixed electron orbits. Let's now look at the distribution of electrons in Class 9 CBSE according to the Bohr-Berry rules. The key formula here is that the maximum number of electrons in any shell is given by 2n squared, where n is the shell number. For example, the K shell, which is the first shell, can hold up to 2 electrons. The L shell, the second shell, can hold up to 8 electrons. The M shell, the third shell, can hold up to 18 electrons, and the N shell, the fourth shell, can hold up to 32 electrons. However, it's important to remember that the outermost shell can hold a maximum of 8 electrons, which is often called an octet. Also, when electrons fill these shells, the inner shells must be filled first before electrons are added to the outer shells. Now, let's talk about valency. Valency is essentially the combining capacity of an atom, and it depends on the number of electrons in the outermost shell, which we call valence electrons. For example, sodium, which has the electron configuration 281, has a valency of 1 because it has 1 electron in its outermost shell. Magnesium, with a configuration of 282, has a valency of 2. And oxygen, with 26, has a valency of 2 because it needs 2 more electrons to complete its octet. Understanding these concepts helps us grasp how atoms bond and interact, which is fundamental to the overall structure of the atom and our study of chemistry. Now let's look at what we mean by atomic number and mass number. The atomic number, which we denote as Z, is simply the number of protons in an atom's nucleus. It's what makes each element unique. The mass number, A, on the other hand, is the total number of protons and neutrons, the nucleons, in the nucleus. For example, in carbon, Z equals 6 because it has 6 protons, and it equals 12 because it has 6 protons and 6 neutrons. Moving on to isotopes and isobars. Isotopes are atoms of the same element that have the same atomic number but different mass numbers. Think of hydrogen, which has isotopes like hydrogen itself, deuterium and tritium, or carbon-12 and carbon-14. These isotopes have different numbers of neutrons, which affects their mass but not their chemical properties. They have practical uses too. For example, uranium isotopes are used as nuclear fuel, cobalt isotopes in cancer treatment, and iodine isotopes in treating goiter. Now, isobars are a bit different. They are atoms of different elements that happen to have the same mass number but different atomic numbers. For example, calcium, which has Z equals 20 and A equals 40, and argon, with Z equals 18 and A equals 40, are isobars. They have the same total nucleons but are different elements because they have different numbers of protons. Finally, we'll briefly touch on the structure of the atom. The nucleus is at the core, containing protons and neutrons, and electrons orbit around it in various energy levels. Understanding this structure helps us grasp how atoms behave and interact, which is fundamental to our overall understanding of chemistry and physics. Let's go through the key takeaways about the structure of the atom. First, the atom consists of a nucleus, which is made up of protons and neutrons, and electrons that orbit in shells around the nucleus. This basic structure is fundamental to understanding atomic behavior. When we talk about stability, Bohr's model provides a clear explanation. It shows how electrons occupy specific energy levels, which helps us understand why atoms are stable under certain conditions. Next, the concept of valency is important. Valency arises from an atom's tendency to complete its octet, meaning it wants to have 8 electrons in its outermost shell. This explains how atoms form bonds with each other. We also need to understand isotopes. These are atoms of the same element, so they have the same number of protons but different numbers of neutrons, leading to different masses. Similarly, isobars are different elements that have the same mass number but differ in their atomic numbers. Recognizing these differences helps us understand atomic variations in nature. Overall, these points give us a comprehensive view of atomic structure, which is central to understanding chemistry and how elements interact in the universe. Now, let's talk about the range of academic tutorial services we offer. We provide support to students across primary, intermediate, and senior secondary classes, specifically catering to the CBSE board as well as other relevant examination boards in India. Our services are flexible, available both offline and online, to ensure accessibility and convenience for all students. Our goal is to help students excel in their exams and strengthen their understanding of the curriculum. And this is where Class Cloud comes into play. It's designed to elevate your learning journey. Think of it as a platform that makes learning more engaging, more interactive, and more tailored to your needs. Whether you're preparing for your board exams or looking to improve your grasp of subjects, our services are structured to support you effectively at every stage. So, in essence, we're committed to providing comprehensive academic assistance that adapts to your learning environment, be it online or offline, and helps you achieve your academic goals.